Good morning, class. Today we're going to learn about the formation of igneous rocks. So I have two goals for you by the end of today's lesson. The first goal is that you guys will know how igneous rocks are formed. The second goal is you know the difference between intrusive and extrusive igneous rocks. So we're going to start off, we're going to take some notes. The sub will walk around and monitor that you are taking notes. You may handwrite these notes. You may use your iPads and type them. I will make this video online through the setup of the app that we set up yesterday through your SharePoint, so you'll be able to access this video in case it goes too fast and you need to catch up and rewatch it. You could do that on your own. So first of all, formation of igneous rocks. Now from the rock cycles, igneous rocks are a type. When some lava volcanoes erupt, they eject a flow of molten rock material. So remember, this is the whole process on how these igneous rocks are recorded. Now you need to write down everything I say or everything that you see up on the screen, unless I tell you not to. Unless I tell you not to. Okay, molten rock material called magma flows when it is hot and becomes solid when it cools. Molten rock material called magma flows when it's hot and becomes solid when it cools. When magma cools and hardens, it forms igneous rocks. So when hot magma cools and hardens, it forms igneous rock. So the process of magma cooling is what's going to form your igneous rock. So that's our first goal. How is igneous rock made? It is made by the hardening of magma cooling. Now we're going to see how this process next develops the igneous rock. Alright, so now let's take a look about magma. We're going to talk about it more in chapter 12 when we study on volcanoes, but here's just some interesting facts that you need to record about magma, or magma as Dr. Evil would say. First of all, most magmas come from deep below the Earth's surface. Magma is located at depths ranging from near the surface to about 100 miles below the surface. So you think of the distance between Powell and Powell and Billings. We have magma that deep below us, about that 100 miles. So if I was taking notes, I would start off, I'd say magma comes deep below the Earth's surface. Magma is located at depths of 100 miles below the surface. Now this next thing, this is just crazy about magma. Temperatures of magma range from 1200 degrees to 2190 degrees Fahrenheit depending on their chemical compositions and the pressures exerted on them. I mean, guys, this is hot. I mean, we can't even really replicate this on the Earth. I mean, it is so hard. I mean, we can melt rock, we can create steel, we could create iron, we could do all that stuff. But I mean, this is just naturally underneath the Earth. This is how hot this is. 1200 degrees Fahrenheit to 2192 degrees Fahrenheit. I mean, oh my gosh. I mean, if you even got near this stuff, it's game over. I mean, that's how hot this has to be. And this process of cooling, that's what's going to create our wonderful igneous rocks. Whenever I pause like that, I'm just giving you guys time to type or write with your notes. Remember, if I go too quickly on this, you have two options. One, the whole class could raise your hand and you pause the video. That's option number one. Option number two, again, I'm going to make this video available on my classes site on the SharePoint app, which you guys set up yesterday. So you could go ahead and rewatch this video anytime you want. Lucky you. Yeah. Alright, so some more information about magma. Some more information. This slide right here, you don't need to write down. You just get to enjoy and listen. So here's some more good information about magma. First, the heat that melts rocks comes from the sources within the Earth's interior. We're going to learn about this when we talk about space, how this source was created, and how this heat is continually renewing itself. And we hope that this heat doesn't quit, because it's not good for the Earth at all. Like, our atmosphere is just going to go bye-bye if the center of the Earth cools. But we'll talk about that when we get to space. Next thing, magma. One source is the decay of radioactive elements within the Earth. That's one source of the heat. Okay, so that's one source of the heat, is radioactive elements decaying. Some of the heat is left over from the formation of the planet, which originally was molten. And this is really cool. I've got some awesome videos I'm going to show you about how we're going to take a look at the Earth was formed, how it was this great big ball of just burning rock just flying around the sun at millions of miles an hour. It's just craziness. And again, we'll hit that when we hit space, but this is how come the center of the Earth is just full of heat and generating this molten rock called magma. Now, radioactive decay of elements contained in these rocks balances some of the heat loss as the Earth continues to cool. Remember, when the Earth completely cools, and we'll talk about this in space unit, it's not good. We're actually going to lose our atmosphere because we'll lose our Van Allen radiation belts. So again, you didn't have to record this slide. This was just some really good information for you. Now, this next slide, yes, we need to talk about. So you need to write this down. So first thing, again, with magma, because magma is less dense than the surrounding solid rock, it is forced upward towards the surface. Okay? So it's not as dense, so it's just going to want to go up. It's going to work its way all the way to up. It's like this. If you were to take some oil and some water, mix it together, and then if you give it time, eventually that oil, since it's not as dense as the water, is going to rise to the top, and it's going to be on the top of the surface, while the water is going to be on the bottom of the surface. Same principles applying here. Magma is not as dense as the rocks around it, so it's going to rise to the top. Now, when magma reaches the Earth's surface and is exposed to a lot of oxygen, it changes its name. It changes from magma to lava. So when magma reaches the Earth's surface and flows from volcanoes, it is called lava. It's called lava. Again, lava or magma, both of them are going to form igneous rocks, but determining whether the rock is formed from lava or whether it's determined if it's formed from magma, it's going to be whether it's an intrusive or extrusive igneous rock. All right, let's go ahead and let's take a break. So please press pause. All right, welcome back from break. Now we're going to spend the next little bit of class time. We're going to talk about how intrusive igneous rocks are formed and what are extrusive and igneous rocks. So first thing, what I need you to do, and I'm going to give you about, let's go with about a minute. You need to sketch this drawing into your notes. Okay, so you need to have a basic sketch showing a volcano. You need to show a magnet chamber down here with the pipe going up to the caldera, with the lava flowing down. Label magnet and label your intrusive igneous rock where it's going to form. And then we'll talk about extrusive. So here we go. You got your time. Most of you should have it done by now, so I'm going to give you about 30 seconds. Go ahead and go. All right, so you should have your picture drawn. So now let's go ahead and let's talk about this formation of rocks and how rocks form. First of all, as the magma is cooling, we've learned that when magma cools, it forms minerals. Now what happens is these minerals, what they're going to do is they get attracted to each other. So you have some minerals forming over here as magma cooling. You have some minerals going over here, and they're like, hey, look at you, mineral. And the other mineral's like, hey, I like you, mineral. And so they see each other, and they're naturally attracted to each other, so they'll start growing towards each other. Well, when these mineral strains start growing together, they get larger and larger and larger. And as you get more and more minerals coming together, you get these crazy things that are found all over called rocks. And so again, the process of how the igneous rocks form is when you have minerals form from when the magma cools. Remember, the crystal size is determined by how fast the lava cools. Now, again, you get these little minerals. They start forming. Well, they like each other. They like to be next to each other. They like to continue the pattern. So they come together really, really nicely, and then they form a rock because they're attracted to each other, just, kind of like you guys are. Now, let's talk about what an intrusive igneous rock is. Whoa, that's just craziness. All right, I have no idea why it did that, so let's go ahead and let's fix this up a little bit, and let's make this something that we could read. All right, so, well, that's just craziness. Rocks that form from magma below the Earth's surface are called intrusive. So rocks that form from magma below the Earth's surface are called intrusive. So intrusive igneous rocks are the ones that are formed below the surface. So right here, you have some magma cooling. That is going to be your intrusive igneous rock. So this magma right here is going to be your intrusive igneous rock. And there's different type of igneous rocks, which you're going to find out in a little homework assignment, that are formed. So there are different forms of intrusive igneous rocks. Now, extrusive igneous rocks. So again, we're going to stay with this same picture. Remember, once this magma reaches the surface and it comes in contact with all this air and it starts flowing down, it's going to cool also. And it's going to do the same thing. The minerals are going to get together. They're going to like each other. They're going to form the mineral strands. When those mineral strands get large together, you get the special mineral. These a whole bunch of minerals, and they're called rocks. Okay, they're all over. Now, sometimes when they form on the outside, they're called extrusive igneous rocks. Alright, so now you can see right here, extrusive igneous rocks are formed as lava cools on the surface. So where your extrusive are going to form is right here in this cooling lava field. That's where your extrusive igneous rocks are going to form. So you go ahead on your picture, you need to add extrusive igneous rocks are formed as lava cools on the surface. Now the problem with these extrusive rocks is the minerals are going to be much smaller because it's going to cool very, very quickly. So you're not going to get really big rocks forming here. You're going to get smaller igneous rocks. We see these bigger intrusive igneous rocks because we have this thing called plate tectonics, which is going to cause uplift, which is going to expose this great big igneous rock here to the surface, and that's how we know about this process. So, all right, so what we're going to do right now is you're going to have a little homework assignment. So what I'm going to need you to do is go into your SharePoint app. You're going to go to 8th grade science, and you're going to download the document that's going to be called Homework Assignment Thursday or something like that. Or it might be called Classifying Igneous Rocks. You'll download that. It's very simple. What you're going to do is you are going to find one example of basaltic, granitic, and andesitic igneous rocks. You will summarize what type of those rocks are, and you will find one intrusive example and one extrusive example of these rocks. Again, the worksheet explains exactly what you need to do. That will be due on Monday. If you have any questions, shoot me an email. Have a great day, guys.